Hello there and welcome back. We're looking at session 3 today, and in the previous session we looked at the programming tools. So we will be looking at flowcharts and pseudocodes, which basically are the tools we use to come up with algorithms that will help us to solve the programming problems. Let's get started by looking at the objectives. By the end of this session, you'll be in a position to explain what is an algorithm. You'll also be in a position to explain what is a flowchart and also what exactly is pseudocode. Let's get started. Overview of programming tools. Now, if you remember from the previous session, we said that the programmer has to plan and write down a solution to a problem in a particular manner, and basically this is known as the algorithm. The two tools used to do this basically are the flowchart and pseudocode. We start by looking at an algorithm. Now, an algorithm is an ordered set of instructions, and the algorithm should have the ability to alter the order of execution of instructions. And the three types of statement constructs that an algorithm can have are given below. We have sequence, or what we call sequential, condition. Basically, this is where your program makes decisions. And we have iteration or repetition. That is when your computer needs to go through or repeat some statements a number of times. After understanding what is an algorithm, the next thing we need to do is to see how to go about coming up with algorithm. And as we've looked at earlier, we've said there are two tools. We have the flowcharts and the pseudocode. Let's start by looking at the flowcharts. Now, a flowchart is a graphical representation of an algorithm, and it charts the logical flow of instructions or activities in a process. Flowcharts help programmers to view how the statements in a program are interrelated, and each activity in a flowchart is depicted using symbols. Let's look at the various symbols and their description. We have this ellipse or the rounded rectangle, and its work is to mark the start or end of a program, and they're represented as rounded rectangles. We have the rectangle, which basically is used for any process, function, or action, and basically this is a rectangle. We have the parallelogram, and basically this represents anywhere that you're accepting or displaying input or output instructions. And basically we've said it's represented as a parallelogram. We have the diamond. This is used to represent decision making and branching statements, and is represented as a diamond. We have the circle. We use it to represent the exit to an entry from another part of the same flowchart, and we call this a connector. Now, this is especially when you have a very long program and it spans multiple pages. You can actually use this. Then we have the arrow pointing down and the one pointing up. And these basically are used to show the flow of control. And we call this the flow lines. Let's look at an example. Consider a program accepting two numbers from the user and displaying the sum of two numbers using the third variable. The flowchart for this example is shown in the following figure. Now I want to look at the steps of how to go about this. Now our program is going to start at the top here, whereby we are going to denote the start of the program. We are going to get two inputs from the user. That is the first number A and the next one B. Then we'll do an operation. We'll add A to B, then assign the sum of these two numbers to C. Then after that, we display the sum of the two numbers and our program ends. Now you can see here we have the terminal symbol, which is used to show the beginning of the flowchart. We have an input-output symbol, which is used to accept the two numbers or get input. After that, we have the process symbol. This is used to add the two numbers. This is usually done by the processor. After that, we display or give feedback to the user. We are using an input-output symbol, which is used to display the sum. Here we have the terminal symbol, which is used to end the flowchart. Some of the essential points to be considered while drawing a flowchart are given below. Number one, initially concentrate on the logic of the problem and draw out the main path of the flowchart. Maintain a consistent level of detail for a flowchart. A flowchart must not contain minute details. Only the essential and meaningful steps need to be represented. Common and easy to understand words should be used, and there should be a consistent usage of variable names. We look at how to go about naming your variables later, and of course, what variables are. Flow should be from left to right and top to bottom. And please note that you can only have one start and stop point. And your flowchart should also be simple. Advantages of using flowcharts are given below. One, they're easy to understand. Of course, if you remember the example we had, it was quite easy to understand what it is that we are doing. It gives you an effective analysis of the problem. It shows effective joining of the different parts. It makes it very easy for you to actually code the solution. There's systematic debugging. We'll see what this means, and also systematic testing. Okay, also we have the disadvantages of flowcharts, and they're given below. One, they're time consuming, especially if you have to draw everything by hand. They are difficult to change once you draw them. And more often than not, usually don't have standards. There are people who like doing things on their own way. Okay, having seen the advantages and disadvantages of flowcharts, let's look at the best practices that you would use to come up with a flowchart. The best practices for drawing flowcharts are as follows. Number one, the direction of the arrow flow should be to one side, either from top to bottom or from left to right. Standard symbols must be used in a flowchart so that they can be understood by everybody. All the symbols in a flowchart must be named appropriately. The use of connector symbol for complex flowcharts, and the size of the symbols used in the flowchart must be consistent. After we've understood how to draw flowcharts and the best practices for drawing them, let's now move on to pseudocode. Now, the word pseudo means false. As the name suggests, pseudocode is not actual code. It's a method of algorithm writing which uses a certain standard set of words which make it resemble code. However, pseudocode cannot be compiled or executed as code. Now, each pseudocode must start with the word begin or start and end with an end or stop. Just like you remember in our flowchart, we were actually using the rounded rectangle to denote the start and end of our flowchart. Now, when you're doing pseudocode, you start with begin, okay? And when you begin, you end. When you start, you stop. Please note that. The statements between the start and end are English phrases and indented to make the word start and end stand out. To display some value, the word display, write, or print is used. To accept a value from the user, the word input or read is used. The pseudocode shows the process to store the sum of variables in a third variable and then display the value stored in this third variable as shown in the example. Now it's the same program we had earlier, the one we drew the flowchart. Let's look at how we would go about this writing pseudocode. Begin, input A, B, A then B, okay? Then we do the calculation, A plus B, assign the result to C, then you display C, and then end your pseudocode. A set of instructions or steps in a pseudocode is collectively called a construct, and there are three types of programming constructs, namely sequence, selection, and iterations. We'll also see that these have other names as we learn more about this. Let's move on. Some of the rules to be followed while writing pseudocode are as follows. Number one, the pseudocode must be easy to understand by all, not just the programmer. The variables mentioned in the pseudocode must be self-descriptive. Avoid using abbreviations and shortened versions of words in the pseudocode. The pseudocode must not contain actual programming code, but should have only the logical steps to show how to operate the code. The reason why we are saying this is that we basically want to create a train of thoughts, and the programmer should be free to implement this in their preferred or favorite programming language. That's why we don't want to have any actual code. Some of the advantages of using pseudocode are given below. It's easy to create. This is just writing or typing it out. There are no symbols, no specific syntax. It's easy to translate, and basically it reduces time. Here we are not drawing, okay? We're just writing or typing things out. Disadvantages, they're given here. There is lack of standards, and it does not focus on the big picture. Now, with that, we want to look at the best practices for writing pseudocode. And the best practices for writing pseudocode are given below. Number one, the vocabulary used to write a pseudocode must be simple to understand and should be on the lines of structured programming. Each statement in the pseudocode must be written in a separate line. Keywords, procedure names, module names must be capitalized in each pseudocode. Use descriptive names that can be understood by non-technical persons also. Maintain consistency when using generic terms such as display, print, end, and so on. Indent the statements as required to show the logical hierarchy. And with that, we've come to the end of the session. Let's go through what it is that we have learned in this session. We have seen that an algorithm can be defined as a procedure, formula, or recipe for solving a problem. And a flowchart is a graphical representation of an algorithm. It charts the flow of instructions or activities in a process. Each activity in a flowchart is depicted using symbols. A flowchart begins with the start or begin keyword and ends with the end and stop keyword. The display keyword is used to display some value to the user in a flowchart. Pseudocode is not actual code. It's basically a method of algorithm writing which uses a certain standard set of words which make it resemble code. Each pseudocode must start with the word begin or start and end with end or stop. The words display, print, or write are used to display some value in a pseudocode. And with that, we've come to the end of the third session. And have yourselves a nice time. God bless. Bye.